correlation, the data will be like, suppose data is the food expenditure. So one is suppose the food expenditure, another variable is the income. So on the one axis we have the like food expenditure, on the y axis we have a income. So we have to see that there's a two brackets like food expenditure. So the individual, the families. So this data is showing like the number of families having the income brackets. So like suppose 10,000 to 20,000. Then we have maybe 20,000 to 30,000. Then 30,000 to 40,000 and 40,000 to 50,000. Suppose these will be the four income brackets and their food expenditure per month. So these are the like income per month of like various four brackets, and we have a food expenditure like 5,000, 6,000, 7,000, 8,000. Suppose these are the four your food expenditure bracket. So that means now we have to show that how many number of families are there who has the income bracket of 10,000 to 20,000 and they have a food expenditure of 5,000. So let's suppose four families are here, then three families are here, 30,000 to 40,000 there will be like 1 and 0. So this is the data given to you, like the number of families who having this relation. Like in the break, four families are there who having an income of 10 to 20 and they have a food expenditure for per month of 5,000. So similarly we have like 6,000 maybe like 1, 2, 3 and 5. And for 7,000 maybe 0, 1, 2 and 8 and 0, 1, 3 and maybe 9. So this is suppose the data given to you. Now you want to calculate that if there is any relation between the two things, that if the if the families have the more income, so they are making more expenditure on their food or not. So if there is any relation between the income and food expenditure, that if the individual income get increased, so he will be taking more expenditure on their food or not, or they remain the same. So like for example, if my salary will increase, so if I make the more expenditure on the food or not. So I want to analyze that thing. That if there is any relation between the two, if income level increase, the food expenditure will also increase or decrease, or there is no effect. So we have to see that particular relation in this grouped correlation. So this 4310 whatever it is, this is the number of families. So the data is X and Y is this income, and suppose X is your income and Y is your food expenditure. And this 4310 that is known as the number of families. So this is the grouped discrete data, you can say. Fine. So now for that reason, you have to first think that if it is a continuous data, so first thing you have to again see the same two criterias like the equal class size. So each class has the equal class size of 10,000 and then the upper limit of the first should match with the lower of the second. So then this both the conditions will get satisfied. So then we can proceed further. So for the further, like we have to take the midpoint of the same. So let's take the midpoint. So we'll take the midpoint of the same. So midpoint will be for this is 10,000 to 20,000. 10 plus 20, 30. 30 by 2 is 15,000. Then you have 25,000. Then you have 35,000. And then you have 45,000. So this becomes your M, which you have to use, that is suppose MX. So this is your MX values, and MY values is this only this 5,000, 6,000, 7,000, 8,000. So this will be your X and this will be your Y. Now again we can use the assumed mean method to reduce our calculations. So assumed mean method means you have to take care of your dx. So if this is your mx, then you have to take with the dx. So your dx values will be like, so dx 15 plus 45. 60 by 2, that is 30,000. So 30,000 and the value nearest to 30,000 you can take as your assumed mean. So the value which is nearest to 30,000 that you can take as your assumed mean. So assumed mean is, so 25 or 35 whatever you want to take you can take. So I am assuming 20,000 as the assumed mean value. So this becomes minus of 10,000. This is your 0. This becomes plus 10,000 and this becomes plus 20,000. So this becomes your value of dx. Similarly, you can calculate the value of dy. So if we calculate the dy in this case, so if we calculate the dy in this particular case, so 5,000 plus 8,000, which is 13. 13 by 2 is 75. So the nearest value is maybe 7,000. So we're taking assumed mean as 7,000 here. So here we are taking the 7,000 as the assumed mean. Here we have taken the 25,000 as the assumed mean. So now the values becomes minus 2,000, then minus 1,000, 0 and plus 1,000. So that becomes your values of this dy. So these becomes the values of dy and this becomes the values of dx. Right? So these are the values of dx and these are the values of dy. So now the formula of this correlation coefficient is, if we are doing the discrete data, so the formula will be like r is equal to n summation xy minus summation x summation y whole divided by n summation x square minus summation x का whole square का under the root and n into summation y square minus summation y whole square का under the root. So here this role of f also comes. So where the n is, so n is replaced with sigma f. So the first part is like sigma n is, the numerator is n sigma xy. So now n is replaced with sigma f. So the formula becomes summation f summation f xy. So initially it was n summation xy. Now it becomes n is sigma f summation xy is summation fxy. So the formula becomes summation f into summation fxy minus, initially it was summation x into summation y. Now it becomes summation fx into summation fy. Similarly, the denominator divided by n summation x square. So now it becomes summation f into summation fx square minus summation, initially it was summation x ka whole square. Now it becomes summation fx ka whole square. So sigma f into summation fx square minus summation fx ka whole square and into sigma f into summation of sigma fy square minus sigma fy ka whole square ka under the root. So that becomes your formula for like grouped correlation. So now we have to calculate the each and every value. So first thing we require in the formula, that is sigma f. So for the sigma f we can do the sum of all these f values. So if we'll make the sum of all these f values, so this f value is like 4 plus 3 7 plus 1 8. Similarly we can add all these values. So this is your 11, this is 11 and this is 13. So this is individual f's. So we have total individual f and then the grand total of this. So it becomes out to be 43. So sigma f value comes out to be 43. So if you do in horizontal or in the vertical way, whatever, so the answer will remain the same. So let's suppose take on this also. So this is 5. Similarly, you can make the additions of all these values and you can make the total of this side also, that comes out to be as 43. So if you either total of this row wise or column wise, the sigma f value comes out to be 43. So we are coming with the sigma f value, that is, so if we'll make the, so sigma f value is 43. So from the data we come out to, we will find the value like summation of all the frequencies. So that value comes out to be 43. Now next thing you want, that is summation fxy. So let's leave this one for a part. We'll do the next term. Next thing you want summation fx. So first you have to multiply with the f into x. So this is your x data. So let's suppose this is your dmx. So now you want f dmx. So you want f into dmx. So this is your f. So this is the f. We have calculated the sum of all this. So summation of f dx. So that you have to calculate like this is your f and multiply by dmx. So these are the respected values of your f dmx. So f dmx is f into the dmx. So this becomes your minus 50,000, and then if you are multiplying all that, so it becomes like 7 into 0. F is your 7 and dmx is 0. So 7 into 0, 9 into 10,000 and 22 into 22. That is your, so this is your f dmx values. Now next is you want summation of this. Some f dmx we have calculated. Now you want the summation of the same. So if we make the sum of this, so the sum of this comes out to be, so next term that you have already calculated, that is f dmx, so which will be equal to 480000. So 4,80,000 will be the value of summation f dmx. Now next you want, similarly you want f dmy. So dmy will be, this is your y, this is your dmy data. So this is your dmx, this is your dmy. So now you have to calculate f dmy. So f dmy you can calculate here. So here you can calculate f dmy, where f is this 8, so which will be equal to 8 and multiply by this f dmy. So minus 16,000 will be the first value of f dmy. Similarly, you can calculate for all the other values. So similarly, you can calculate the values of this, and now again the summation of f dmy you want. So if we make the sum of this, it become minus 14,000. So the value of summation f dmy is minus of 14,000. So that becomes the value of summation. So numerator में हमारी एक value रह गई है, that is summation f. We have already calculated summation f dx dy. So that we'll be calculating maybe a little later. Now comes to denominator. Denominator requires, again first is sigma f. So sigma f we have already calculated. Next term we want sigma f into summation of fx square. So first you have to calculate dmx square. So then, so you want first the values of dmx square. So if you calculate the dmx square, which will be equal to this multiply by this itself, so that becomes your dmx square. So these will be the values of your dmx square. Then you have to multiply this for f dmx square. So step by step you have to do. It's not a, you see the formula, whatever is required, you have to calculate it from the data. So f dmx square, if you are calculating, so f dmx square is, so f is your 5 and multiply by dmx square value you have already calculated as this. So this becomes your f dmx square, individually all the values of f dmx square, and then you have to make the summation. So summation becomes this one. So the value of summation f dmx square. So the value of f dmx square value becomes this one. So this is your f dmx square value. Fine. Then similarly you can find out for f dmy square. So for that you want first is the dmy square. So if we are multiplying this, so this is your dmy. So you have to multiply for dmy square first, so which will be equal to this multiply by this value itself. So this will be our dmy square. Then for all these dmy, so this will be your dmy square. Then you have to multiply f dmy square. So which is your f dmy square. So f dmy square is, you have to multiply this this dy square value with the f. So which will be equal to, this is your f multiply by this dy square. So this will be the values of dy square, and then you have to make the sum of this summation. So that becomes value like So summation of f dmy square, that comes out to be this one. Fine. So now everything will be now minus is summation of f dx ka whole square. So f dx is already calculated as 48,000. So rest everything is like now available to us except the numerator. One thing we have left, that is summation of f into dx into dy. So in the numerator you want summation of n into summation xy. So that is summation f into summation of f dx dy. So there is a multiplication of three things. One is f into dx into dy. So you have to calculate each and every value separate. So like for this cell. So so this is the data we have. So now if we'll take this particular data, so this is your f, this is your dmy, and this is your dmx. So you have to multiply these three values, 4 into minus 10 into minus 2. So in the same way, you have to calculate these all values individually for all the cells. So individually for all the cells, you have to calculate these values. Okay. Uh, so for that, we can calculate like, so we can have this like 4 into minus 2 into minus 10. So that we can solve by like 4. F, this is your f, this is your dmy, and this is your dmx. So this will be the value of the first. Then if you make like this way, so this becomes your f. So in this way you can drag this, because this will lead to, this is your f in this is your dmx, and this is your dmy. Fine. So in this way we can calculate. So this becomes 1 into 10,000 into, so this becomes 1 into 10,000 multiplied by minus. So this is like uh, huh. So this will be moved to the next cell, so we can calculate it manually, or we can have to place the dollars. So we can make it like manual. So 1 lakh, 4 into minus 2 into minus 10. So that is 8 lakhs. Then comes 1 into 10,000, that is 10,000 into minus 2. So we can apply individually formula. 1 multiply by this multiply by this. So that becomes your second value. Third value becomes, this is 0. So let's, 1 is 0, so product is also 0. So here is no need to apply the formula, because so for this all the values is 0. 1 is 0, anything multiplied by 0 is 0. So this becomes also 0. So all these values become 0. So we need not to calculate. That is the advantage of using the assumed mean method. So that all these four values become 0, because this one value dmx is 0. Similarly, because for this dmx is 0 for all those values, so we have to calculate like this also. So this is also 0. Then this four values of this was also 0. So ये सारी zeros हो जाएगी. Now we have to check for the frequencies. So first is this we have already calculated. For this one we have to calculate like 1 multiply by minus 10 and multiply by minus 1. So this will be your this values. Then for this the m is 3, f is 3 multiply by 10 multiply by minus. So this will be like all the values in the same way we can calculate 5 multiply by 20 and multiply by minus 1. Fine. In the same way we can have like this, which will be equal to 0. So this is frequency is 0. So here is the answer is for 0 this. Now this for this it is like equal to 3 multiply by 10 and multiply by 1. And the last but not the least is like is equal to 9 sorry is equal to this multiply by 20 and multiply by 1000. So this becomes the values of f dmx into dmy. So now you have to make the sum of all the values. So we'll make the sum of all. So it will take this. So sum becomes 1 5 1 2 3 4 5 6 7 zeros are there. So it will make the summation of. So it will take these values summation of f dmx dmy. So that is we have calculated. So which will be equal to 1 5. So that will be like if we make the sum here. So which will be equal to this one. So this becomes your summation of f dmx dmy. So everything is like now. So from the data we have calculated all these values. Now we have to use these values in the formula to calculate the Karl-Pearson's coefficient of correlation. So first is the numerator. We calculate numerator and denominator separately. So for the numerator, it is like summation of f into summation of f dxm by dmy. So which will be equal to summation of f into summation of f dmx dmy minus of summation of f dmx and into summation of f dmy. So all these, this becomes my numerator, sigma f summation of f dmx dmy, this value, minus of summation of f dmx into summation of f dmy. So this becomes your numerator. Now comes to denominator. So denominator is, first part of the denominator is again sigma f into summation of f dmx square. So this is your dmx square minus of summation of f dmx का whole square. So this is your summation of f dmx का whole square and पूरे का क्या आएगा, and we have to make the complete under root. So raised to the power 0.5. So this becomes your first part of the denominator. Similarly, second part of the denominator will be like summation of f multiply by summation f dm y square, which will be this value, minus of summation of f dm y whole square and complete under the root. One second. Which will be equal to like L, apply the formula again, one second, is equal to summation of f multiply by summation of f dm y square minus of summation of f dm y का whole square. और पूरे का. So this becomes your second part of the denominator. Now the denominator will be first part into second part, so which will be equal to this multiply by this. So this is your denominator, so r will be equal to, numerator is this one divided by denominator. So 0.613 will be your Karl-Pearson coefficient of correlation for grouped data. So this means that Karl-Pearson's of coefficient of correlation for this data is 0.6136. So which shows that is a positive correlation, which signifies that as the income gets increased, the food expenditure of the family will also get increased. So that is your relation between this, and it is a high positive. You can say that 60% there is a relation that once the individual income is increased, the food expenditure will also increase. But it does not tell that cause effect. It does not tell that whether the first income will increase and then the food expenditure. It can be a vice versa also. It can be like my income increase, then my increasing the expenditure on food. Or the second one is, the second interpretation can be like this: I have increased my expenditure on food, so for that I have to earn more income. So this relation can be understood by regression, that if the first food expenditure will increase and then the income will increase, or if the income will increase and then the food expenditure. But this correlation will only tells me the relation between the income and food expenditure. It does not tell me that whether the income is because of food expenditure or food expenditure is because of income. So that is the, that can be awared by the regression, not by the correlation. So with this correlation, we cannot say like if food expenditure is because of this or age is because income is because of food expenditure. But the thing is, it is showing a positive correlation between the two variables, food expenditure and the income. Clear? One second.